Hey class, remember how I told you that I thought that working with logarithms was kind of like working a puzzle and we got some rules down. We've got a couple more rules to get into this, but now we're getting to the really fun stuff. The expanding and condensing by applying those rules is kind of like playing the game, and I'm so ready to get into it I can hardly wait. So let's go with me. Let's go. So as I said, we're going to have some more rules to apply to this. And the first one is the product rule. I just want you to make sure that as we go through all these rules, all the variables that are in there, m, n, b, x, whatever we're doing, are real numbers. And that base of the log can never be equal to 1. So the first one is the product rule. What we have here is log base 6, and then we have a product. The argument here, by the way, that was called the argument. And what that is a product of two numbers. In this case, it's 7 times 11. Now, the rule says that if we have a product, we can expand that into log base b of m plus log base b of n. So this would become log base 6 of 7 plus log base 6 of 11. On this one, I've got log, and remember when we don't have a base, it's going to be base 10. So it's log 100x. So that's going to, I can expand that into log 100 plus log x. Now, whenever we can simplify one of our expressions, we're going to do so. So this log 100, remember it's log of 10 squared. So that log of 10 squared just simplifies to 2. So we'll have log, or 2 plus log x. The next rule that we're going to look at is the quotient rule. So in the product rule, when we were multiplying the argument, then we added when we did the expansion. On this one, we're going to do division, which is the opposite of product. So the expansion is going to be the opposite of adding. It's going to be subtracting. So let's take a look at the examples. We've got here on this first one, log base 8 of 23 over x. So we're going to expand that, log base 8 of 23, and anything in the denominator is going to be subtracted. So log base 8 of x. And this one, we have natural log of e to the 5th divided by 11. So we can expand that, natural log of e to the 5th minus the natural log of 11. Now remember, if we can simplify something, we're going to. Natural log of e raised to the 5th degree is just 5. And then we'll subtract the natural log of 11. And the final rule that we're going to look at is the power rule. So we're going to have we've got log base b of m raised to a power. We're going to take that, pull that power, and put it in front of the term. So it becomes p times log base b of m. So on our examples, we've got the natural log of the cube root of x. Now, to expand that, it's easier to see that cube root written as a fractional exponent, because then we can take that exponent and pull it out in front. So we're going to have 1/3 natural log of x. On this one, it's real tempting to try to separate that x plus 4, but that's not being multiplied. This has to stay together. The only thing we can do to expand that is bring that 2 out. So I'm going to take 2 log, and it's x plus 4, and that's as expanded as we can get with that one. So here's where it gets really fun. You're going to start including all those rules in one thing. Let me give you an example here. I've got this exponent here, which is going to be 1/5. So I'm going to do log base 2, and I'm going to say it's xy to the 4th over 16 raised to the 1/5. So by the power rule, I'm going to take this 1/5 and pull it out front. So I'm going to have 1/5 times log base 2 of xy to the 4th over 16. Now I can pull all these apart. This one gets added to this one and subtract, and then that one gets subtracted. But it's all going to still have that 1/5 in front of it. So I'm going to have 1/5 log 2x plus, now this is going to be y to the 4th, and I can bring that 4 out front applying that power rule. 4 log y, and then I'm going to subtract, and I'm going to have that log base 2 of 16. Now 16 is 2 to the 4th, so it's really log base 2 of 2 to the 4th, which simplifies to 4. And that is my full expansion. Isn't that fun? You're going to have a blast.